So continuing with these directions, so we're on page 3. So we made the A solutions. You should have already calculated the molarity of the product using limiting reactant and stoichiometry. Now we're going to measure the absorption of the A solution. So you're going to put this into your data table right here. So you're going to go to the student data set that I assigned you and enter the absorption that is listed for your particular group in each of those boxes. Next, we're going to make a scatter plot with Excel. So with Excel, you're going to use columns A, B, C, rows 1 through 8. Title your headings as we have here, and then label each solutions, and then just a quick note for how to enter a number in scientific notation. What you actually just enter in to this to get scientific notation on Excel, 2e negative 5, and then press enter. So 3e negative 5 and press enter. Okay, so these are numbers that I just made up. Yours will be different, and your calibration curve will look something like this. On the left, what's important is to fit your data to a trend line, display your equation and your R-squared value, because we'll be using that next. Give your graph a good x-axis, y-axis, and title. I will create a separate video that goes over how to create that graph if you don't remember from a previous class.
You done again?
No.
Still recording?
Okay, so now what we're going to do is we're going to measure. Okay, now we're looking at page 5. We're looking now at our B solution. So first we're going to make the B solutions, realizing our B solutions have the same molarity for the iron nitrate and the KSCN. They're both 0.002 molar this time. So what's going to happen, we have similar molarities, similar amounts of each reactant. So we will indeed reach equilibrium. So what you're going to do, you're going to then measure the absorbance of the B solutions, and the B solution absorbance, you're going to go ahead and fill in these data entries, and you're going to get that from the sample student data that I assign your group. Next, we're going to calculate the molarity of the product for each of your B solutions using the equation from your trend line. So this is an example of the equation from Excel that I got. And again, I made up these numbers. Yours will be different. But if you remember the graph that we're looking at, we have the concentration, I'll just call P of our product, and absorption on Y. So Y equals mx plus B can be written as absorption, or ABS, equals 2352 X, and X is our product, molarity at equilibrium, FeSCN2 plus 0.1158. And so what happens, you have the absorbance values because you're write down these numbers. So that'll be just a number. And you're going to plug that in for absorption. And then you can find the molarity of your solution. So because these B solutions reach equilibrium, we cannot calculate the molarity of the product based on a limiting reactant. So instead what we can do is we're going to measure the absorption. The number would be read out on the spectrophotometer. We can then use our trend line that we get from Excel in our A solutions and calculate the molarity of the product. So to do this, you want to rearrange the algebra to solve for FeSCN2 plus. So I'm going to take the absorption minus 0.1158 all over. So divide both sides by 2352 equals FeSCN2 plus concentration. And again, this is an equilibrium value. So for each of your B solutions, B1 through B5, you're going to perform this calculation, and your final number goes in there, the Fe, Sc, and 2 plus. This is indeed at equilibrium, calculated from the calibration curve.